Excellent. So let's move on to horizontal and vertical lines. Now, just as a reminder, we have our Hoy Vux, which says horizontal lines have a 0 slope, and their equations look like y equals some number. Vertical lines have an undefined slope, and their equations look like x equals some number. Write the linear equations given the following information. So, if you have a slope that is either 0 or undefined, you don't have to do a whole lot of work to get your answer. You know all the equations will either be y equals a number if it's a 0 slope or a horizontal line, and x equals a number if it's an undefined slope or a vertical line. So here's what I want you to do to save yourself a bit of time. If you ever see a slope of 0, I want you to interpret that as a Hoy horizontal line. And because it's a horizontal line, you know your equation is going to be y equals some number, because the Hoy tells you that. So my answer is going to be y equals some value. Which value should I pick? Well, use the other piece of information that we haven't yet used. We have a point, -5, 3, where x is the -5 and y is the 3, but the one I'm looking for is the y, because my solution is y equals some number. So my equation is y equals 3. It has a slope of 0, and it certainly does pass through -5, 3. In the next problem, we have m is undefined. Well, because m is undefined, you know this is a Vux problem because U stands for undefined. So this means you have a vertical line, and because it's a vertical line, you know your equation is going to be x equals some number, because that's what the x says in Vux. So we have x is equal to some number is my answer. Well, which number is it? Well, you only have two other numbers left. You have -2, -7, which is the x and the y. In this case, because my equation is x equals some number, I just take the x number from the point, and there is my solution. That is the equation passing through the points -2, -7 with an undefined slope. Now the third problem asks you to find the equation of a line passing through these 2 points. Now clearly you don't have a slope yet, so we are going to have to first find the slope. So we have m is equal to y2 minus y1 x2 minus x1, which is 8 minus a -4 over -7 minus a -7. So negative minus a negative is add a line, change the sign, add a line, change the sign, which gets me m is equal to 12 over 0. When there's a 0 under the line, it's undefined. So because it's undefined, I know this is going to be a Vux problem. So because it's a Vux problem, I know it's a vertical line. Because it's a vertical line, I know my equation is going to be x equals some number. So x is equal to some number is my equation. Well, I have 2 points this time, right? But look at each of the x values. Both of the x values are the same, which just is like a nice little pat yourself on the back. You know this is the solution because both x's are -7. In fact, any point on this line will have all this values of x being -7. Next, we'll be discussing parallel and perpendicular slopes. So parallel lines are two lines that never meet, never cross, never touch. The reason that they never cross or never touch is because they're going in the same direction. Now, when we're talking about direction, we use the word slope to describe a number that represents the direction that the line is going. For example, this top line is going up and over, let's say, I don't know, it's rising A and it's running B. Well, as it turns out, the parallel lines will also be running rising A and running B at the same rate, which is why they never ever meet. They're always rising and running at the same rate, but they start at different places, so they will never meet. What does that tell us about our slopes? Well, if we're rising and running the same, that means the parallel slopes are equal or the same. So whatever the slope of the first line is, a parallel line has to be equal to it. Now that's not quite the same on perpendicular lines. Clearly they're going to cross, and not only do they cross, but they cross at a special angle, and that angle is 90 degrees. I did my best when I was drawing these to get that to be looking like a 90-degree angle. So clearly the slopes can't be equal on this one, on perpendicular lines. First of all, the red line is going uphill and the blue line is going downhill. So in order to be perpendicular, they're going to be going in opposite directions, which tells us that because the red line is looking like it's a positive slope and the blue line is looking like a negative slope, that the perpendicular slopes are, first of all, opposite signs. But that's not all. Let's say you're rising A and you're running B on the red line. As it turns out, the rise and the run are in opposite directions. For example, on the red, we were rising A, which was a little, and running B, which was a lot. On the blue, we're rising B, which is a lot, and technically it's down, right? So it's negative B. And we're running A, which is a little. So rising B, running A. So not only are they opposite, but they're also opposite and reciprocal. So that means if my slope is A over B in red, a perpendicular, and here is the symbol for perpendicular. It's just like a little T upside down. The perpendicular slope would be negative B over A. Opposite meaning positive to negative, reciprocal meaning the numerator and the denominator switch places. To really emphasize this, I'd like to give you a couple examples. So let's say my slope was 2/3. So this is my slope. I want you to be able to get a perpendicular slope. So if my slope was 2/3, what would the perpendicular one be? Negative 3/2. Opposite, meaning positive to negative. Reciprocal, the top goes to the bottom, bottom goes to the top. Okay, well what if I give you a slope of a negative 1/3? What is the opposite reciprocal to negative 1/3? Would be top to bottom, bottom to top. So that's positive 3 over 1. But no one really writes over 1, do they? They just really write positive 3. Okay, well here's a tricky one. What if I give you 5? What is the opposite reciprocal to 5? A lot of people will say negative, which is correct, but the reciprocal, sometimes people have a hard time with a whole number. The reciprocal of a whole number is 1 over that whole number, because 5 can be rewritten as 5 over 1. So when we reciprocate that, that's negative 1/5. So now that we've discussed parallel and perpendicular slopes, we want to talk about the steps in order to write equations of parallel and perpendicular lines. So first thing I want you to do is, if you're given an equation, I want you to put it into slope-intercept form to find the slope. Remember, when you're writing equations, you always have to find a slope. So if they give you an equation, you better find that slope off the equation. Now, if your lines are parallel with the given information, then the slope of the new line is going to be equal to your original slope. But if the lines are perpendicular, then the slope of the new line is going to be opposite reciprocal. Plug this new slope and the given point into point-slope form. because you have a new slope and you have a point, you can use point-slope form. Then you have to solve for y like we've done in the past to get your answer in slope-intercept form. Okay, so I want you to find the equation of a line passing through this point. So here is our x1, y1, but we're not really going to use that until later on. And parallel to this line, y equals 1/3 x minus 7. So the first thing to do is you have to find a parallel slope. So I'm going to rewrite my line, y is equal to 1/3 x minus 7. Step 1 says to put the given equation at a slope-intercept form. Check, it's in slope-intercept form. And what is the slope of your line? Well, I can just pull it right off. My slope is 1/3. Now, I don't really care about this slope. What I care about is a parallel slope. This is shorthand for parallel, by the way. So what is this? If the slope is 1/3, what is the parallel slope? Well, they're going to be equal, so my slope will also be 1/3. So my new slope is 1/3. I'm going to take that, and I'm going to use that slope and the point to get an equation, which is very similar to when we found equations passing through 2 points. Find the slope. Now, we found the slope a little different. We didn't use a formula. We used the properties of parallel and perpendicular, but then the rest of it's going to be the same. Use the slope, which we said was 1/3, and the point, which we said was 4, 5 from the problem, and then we plug it into point-slope form. So we have y minus y1, which happens to be 5, equals m, which is 1/3, parentheses x minus x1. In this case, x1 is 4. So this is an answer, but it's not in the right form. So step 4 says to solve for y to get it in the right form. So we have 1/3 x minus 4/3. Going to add 5 to both sides. So that gives me y is equal to 1/3 x negative 4/3 plus 5. I don't know in the top of my head, so I have to use a little bit of fraction work on the side of my paper. So that's 15/3, and negative 4/3 plus 15/3, which gets me 11/3. So this is truly the equation of a line passing through 4, 5. If you'd like to check it, you could take 4, 5 and plug it in and make sure that it works. And it is parallel to the line y equals 1/3 x minus 7 because their slopes are the same. Let's try a perpendicular problem. The equation of a line passing through negative 4, 2, again, that's my x1, y1. And this time I'm perpendicular to this line. So I have to, step 1, find my slope. This time I'd say perpendicular slope. So we have y is equal to 1/3 x plus 7. First step says to put it into slope-intercept form. Check, it's done. What is the slope of this line? It's 1/3. But that's not the slope I care about. I care about the perpendicular slope. So what is perpendicular to 1/3? Well, opposite meaning positive to negative, and reciprocal 1/3, change this to 3/1. We're just going to go ahead and write that m equals negative 3. So now that I have a slope, I'm going to use that slope and my point to get my equation. So my slope is negative 3. My point is negative 4, 2, which is x1, y1. And then I use point-slope form. Y minus y1 equals m parentheses x minus x1. So we have y minus y1, which is 2, equals m. Is m negative 3 parentheses x minus x1. And in this case, x1 is negative 4. Again, this is an answer. It's just not in the right form, so I'm going to clean it up by distributing That's y minus 2 equals negative 3x. Add a line, change the sign, that's plus 4, so when I distribute that gets me negative 12. And then I add 2 to both sides, and I have y is equal to 3x minus 10.